Hey everyone, thank you so much for sticking around whilst I was dealing with my technical issues. This wasn't a live demo issue. I'm going to do a live demo later, and I promise there'll be issues there as well. But thank you for being here. My name is Peter Pistorius. I'm the co-creator of a framework called Redwood.js. I'm also the co-founder of a company called Snaplet. Today, I'm here to convince you that you should be programming against good data. In computing, there's this term called garbage in, garbage out. It's quite simple. For any given input, garbage in, you're going to produce results that are bad, garbage out. Think about it. When we as programmers are working with bad data, it's incredibly difficult to make decisions that are correct. It's almost as if the foundation of the software that we're building is flawed. I'd like to show you some examples where bad data produced bad code or bad results. So this is Joy. She describes herself as a code poet. She was working on she was a student, and she was tasked with creating a social robot that could play peekaboo. Now, if you're a kid or a parent, you've played peekaboo. It's you close your eyes, you open your eyes, and you say peekaboo. And then someone else takes a turn. The problem was that this robot couldn't detect her face. She was on a deadline, so she borrowed her roommate's face, and she submitted her application, and then she thought someone else would figure this out a couple of weeks later. But then she was invited to a programming competition in Japan. And when she got there, there was also a social robot, and everyone else was playing against it, except that when she tried to play against the robot, it did nothing. It just didn't see her as a human being. So she tracked down the developers, and she asked them, hey, I had this similar problem. What's going on here? And they figured out that they were actually using the same software library, the same facial detection software library. So what's going on here? The problem is that the data that they used to train that algorithm simply didn't reflect the reality of the world that we live in. We live in a world that is interconnected, and software can travel the world in a couple of seconds. Luckily, there's a super easy fix for this. All you got to do is give it better data, and you'll get better results, not garbage in, garbage out. The bigger issue here is actually awareness. So Joy actually started the Algorithmic Justice League, where she tries to educate developers on what good data is and how you can fight bias in your data sets. Here's another example, and this is more close to home. There's an article that came out about 10 years ago called Falsehoods That Programmers Believe About Names. And it highlighted just how well we misunderstood our world. So we operate with bias. We see the world through our own lens, and we build software using that lens. And we're going to introduce problems. Here's just some interesting examples that I was able to find. Your name can only contain letters. There are people in the world that don't only have names in their letters, and you can see this is from KLM in 2023. It's not that long ago, and they just wouldn't accept his name as something that was valid. Names have fixed lengths. A name can't be more than 2 characters. A name can't be more than 25 characters. Here's a fun fact. This is the man that has the world's longest name. It's all that there, or written as Alfred Wolf plus 666 Senior. That 666 makes me think that perhaps his parents were trying to play a trick on society, but that's what we got. So, by definition, a name cannot be invalid. It's something because it's something. Because when someone tells you their name, that's appropriate. So we got a problem there. There are also falsehoods that programmers believe about time. And yesterday was a leap year. So there was actually a Hacker News thread about February 29th, where this person was asking, hey, did anyone else come across some interesting examples from yesterday? Yesterday being February 29th. In China, the legal age to get married is 22 years. So what they do is they take the date They subtract 22 years, and then they try to see if it's valid. So what they did was they took 2024 minus 22, which gave them 2002, the 29th of February, which isn't a valid date. So everyone who tried to get married yesterday couldn't, because of the data that they were operating at, the assumptions that they operated against were false. Here's another one. This person unsubscribed from Netflix. They were meant to have an extra day of watching. They didn't. It's kind of ridiculous. And here's another one. Cloudflare issued an invoice with the date of 1970-0101. And we're all laughing because these are like so obvious. But when you're building code, you just don't think about them. And that's why you have to have really good data whilst you're building software. Yeah, so what's going on here? The developers that are writing this code are not bad at their jobs. They just understand the world using the information that's available to them, their bias. But a lot of these can be solved by giving developers access to really good data, production-like data. Typically, there are two approaches to solving this. The first is, in a relational database, is you actually directly copy production. You transform the data, removing all the private information, and you put that onto your development environments. The second approach is way more exciting. It gives developers full control, and that's that you generate the data. You use an API to tell the computer what you want, and you get data out. I'm going to show you a quick demo. This is where we're going to get some more technical issues that I promised you earlier, of a product that does this. It's one that I'm working on called Snaplet. Let me just open up VS Code here. VS Code. And drag this over here. Sorry, this is full screen. Oh gosh. There we go, finally. Oh, no. Oh, this is ridiculous. Okay. Right, what I want to show you is an application that will introspect your schema of your database. It'll figure out what kind of data that you are meant to put in there, and it will generate it for you when you ask it to generate something. So I just want to show you what the schema of this database looks like. Shit. Let's go here. So this is a restaurant booking application. Customers can create a reservation for an available table on a particular date for a particular restaurant. So typically, when you want to put data into this database as a developer, say for instance you want to create 3 reservations, what you will end up doing, I'm just going to mirror these screens. Sorry, I'm operating on. Okay. So typically what you would do is you'd say, I want some reservations. Unfortunately, this table is just references to other tables. So you have to go and fulfill the relations of all the data that this table wants. So you'll create some customers. You'll go in and you'll say, OK, I want some, oh, not that. You'd say, I want some customers. You'd make up some email addresses, make up some phone numbers. And then you go and create restaurants and set availabilities. And then finally, you'd get to the point that you wanted, which is reservations. We all do this. We've done this 1,000 times. It feels bad, but you just kind of do it and get it out of the way. So Snaplet is a tool that automates a lot of that for you. So it's a TypeScript SDK that gives you access to data ORM. I like to think of it as if Prisma and Faker.js had a baby, and it gives you this ability to create awesome data sets. So what I'm going to do is tell Snaplet that what I want is reservations. And I want 100 reservations. I'm going to go ahead and run that, npx tsx c.mts. Oops, it's spitting out the SQL. I'm just going to actually insert it into the database. So what Snaplet has done is it understood the relationships of my database. It understood what I was inferring by naming my columns a certain way, and it just inserted all that data into my database. So if we have a look at our customers, you can see that I have 100 customers. They all have email addresses. They all have phone numbers. We have restaurants, same kind of thing. They all have business names. They have addresses. They have websites. There's table availability. And there's reservations. And over here, by the table number, you can see that the numbers are kind of crazy, and the available seats are kind of crazy. So Snaplet also gives you the ability to model your data to reflect real-world scenarios using TypeScript. So what we can do is just say, hey, for that table availability column, the one that was terrible, the available seats, what I want to do is return a range. I'm just going to run that again. And you'll see the range is between the boundaries that we specified. And there's so much more that Snaplet can do for you. If you are working against a relational database and you want really good data to code against, I'd love to talk to you more. Thank you. That's the end of my talk.